we want to calculate moment of inertia of next object. Next object is annular ring. Okay. So yesterday we derived expressions for moment of inertia of circular disc. In a circular disc ಗೆ 3 different axes ನಲ್ಲಿ ನಾವು moment of inertia calculate ಮಾಡಿದ್ವಿ. ಜ್ಞಾಪಕ ಇದೆಯಾ?
Yes, sir.
Okay. ಅದ್ರಲ್ಲಿ ಏನಾದ್ರು ನಿಮಗೆ ಸ್ವಲ್ಪ ಡೌಟ್ ಇದ್ರೆ ಬೇಕಾದ್ರೆ ನಾನು ಆಮೇಲೆ ಮತ್ತೆ ಒಂದ್ಸಲ ಹೇಳ್ತೀನಿ ಆಮೇಲೆ. But anyhow, let me continue this part. Okay. Now we want to find out moment of inertia of another device ಅಥವಾ another object. It is annular ring. Annular ring ಅಂತಂದ್ರೆ I think you know what is the ring. Ring ಅಂದ್ರೆ ನಿಮಗೆ ಗೊತ್ತಿದೆ ಅಂತ ಅನ್ಕೋತೀನಿ. ತುಂಬಾ ಈಸಿಯಾಗಿ ಹೇಳ್ಬೇಕು ಅಂತಂದ್ರೆ ಸೊ ಟೆನಿಕಾಯ್ಟ್ ಅಂತ ಒಂದು ರಿಂಗ್ ಆಟ ಆಡ್ತಾರೆ. ಜ್ಞಾಪಕ ಇದೆ ನಿಮಗೆ? ಯೂಶಲಿ ಹುಡುಗಿಯರು ಜಾಸ್ತಿ ಆಟ ಆಡ್ತಾರೆ. ಒಂದ್ ಸೈಡ್ ಇಂದ ಇನ್ನೊಂದ್ ಸೈಡ್ಗೆ ರಿಂಗ್ ಎಸಿತಾರಲ್ವಾ, ಅದನ್ನ ಕ್ಯಾಚ್ ಹಿಡ್ಕೊಂಡು ಮತ್ತೆ ಆಪೋಸಿಟ್ ಎಸಿತಾರಲ್ವಾ. ದಟ್ ರಿಂಗ್ ಇಸ್ ವಾಟ್ ವಿ ಕಾಲ್ ಇಟ್ as ಟೆನಿಕಾಯ್ಟ್ ರಿಂಗ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆ. ಸೊ ಟೆನಿಕಾಯ್ಟ್ ರಿಂಗ್ ಇಸ್ ಅನ್ ಎಕ್ಸಾಂಪಲ್ ಫಾರ್ ಆನ್ಯುಲರ್. ಓಕೆ. ಅಥವಾ ಇನ್ನೂ ಸರಳವಾಗಿ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ಬೇಕು ಅಂತಂದ್ರೆ ಸೊ ಹುಡುಗಿಯರ ಕೈನಲ್ಲಿ ಇರುತ್ತಲ್ಲ ಬಳೆ, ಅದು ಕೂಡ ಆನ್ಯುಲರ್ ರಿಂಗ್, ವೆರಿ ಥಿನ್ ಆನ್ಯುಲರ್ ರಿಂಗ್ ಆಗುತ್ತೆ. ಅಥವಾ ನಿಮ್ಗೆ ಸ್ವಲ್ಪ ತಿಂಡಿ ಇಷ್ಟ ಇದ್ರೆ ಕೋಡ್ಬಳೆ ಗೊತ್ತಲ್ವಾ ನಿಮ್ಗೆ? Yes, ಕೋಡ್ಬಳೆ is also annular ring. Okay. So here we are calculating moment of inertia of an annular ring. Okay. So this is the diagram of annular ring. Idu ring idu. Okay. ಒಳಗಡೆ I think you see O is the center. So O is the center. ಒಳಗಡೆ R1 is the radius ಅಂತ ಹಾಕೊಂಡಿದೀವಿ. ಸೊ ಇನ್ನರ್ ಮೋಸ್ಟ್ ಸರ್ಕಲ್ ಕಾಣಿಸ್ತಿದೆ ಅಂತ ಅನ್ಕೋತೀನಿ. ಇನ್ನರ್ ಮೋಸ್ಟ್ ಸರ್ಕಲ್ ಒಳಗಡೆ ಖಾಲಿ ಇರುತ್ತೆ, ಏನೂ ಇರಲ್ಲ. ಇದು ರಿಂಗ್ ಆಗ್ಬೇಕು ಅಂತಂದ್ರೆ ಫುಲ್ ಸರ್ಕ್ಯುಲರ್ ಶೇಪ್ ಆಗಿರ್ಬೇಕು, ಮತ್ತೆ ಸೆಂಟರ್ ಅಲ್ಲಿ ಒಂದು ಹೋಲ್ ಇರಬೇಕು ಅಲ್ವಾ? ಜನರಲಿ ಯು ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ annular ring. ಕರೆಕ್ಟಾ?
Yes, sir.
Yes. So therefore please remember this is an annular ring in which there is a hole at the center. ಮಧ್ಯಭಾಗದಲ್ಲಿ ಒಂದು ಖಾಲಿ ಜಾಗ ಇದೆ. ಅಥವಾ ನೀವು ಹೋಟ್ಲಲ್ಲಿ ವಡೆ ತಿಂದಿರ್ತೀರಲ್ವಾ, ವಡೆನ ಅಷ್ಟೇ ಮಧ್ಯದಲ್ಲಿ ತೂತ ಇರುತ್ತಲ್ವಾ, ಸೊ ಹಾಗಾಗಿ ಅದು annular ring ಆಗುತ್ತೆ. ಸೊ ಆ ತರ ಇಲ್ಲಿ ಖಾಲಿ ಜಾಗ ಇದೆ. ಓಕೆನಾ? ಸೊ ಹಿಯರ್ ದಿಸ್ ಇಸ್ an annular ring. Inside radius of the annular ring is R1. Outside radius is R2. ಒಳಗಡೆ ಚಿಕ್ಕ ಸರ್ಕಲ್ ಕಾಣಿಸ್ತಿದ್ದಿಲ್ಲ, ಫಸ್ಟ್ ಸರ್ಕಲ್ ಕಾಣಿಸ್ತಿದ್ದಿಲ್ಲ, ಅದರದ್ದು ರೇಡಿಯಸ್ R1. ಸೊ ಹಾಗಾಗಿ ರಿಂಗ್ದು ಇನ್ನರ್ ರೇಡಿಯಸ್ R1 ಆಗುತ್ತೆ. ಔಟರ್ ಮೋಸ್ಟ್ ಆಚೆ ಕಡೆ ಫುಲ್ ಹೊರಗಡೆ ಪೂರ್ತಿ ಹೊರಗಡೆ ಇರೋ ಇನ್ನೊಂದು ಸರ್ಕಲ್ ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ, ಸೊ ಅದು ಔಟರ್ ಮೋಸ್ಟ್ ಎಡ್ಜ್ ಆಫ್ ದ ರಿಂಗ್ ಆಗುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ ಅದರದ್ದು ರೇಡಿಯಸ್ R2. ಸೊ R1 and R2 are the inner and outer radii of the given annular ring. Okay na? And we are assuming ring has a mass of m. Okay. So area of the face of the disc ಅಥವಾ face of the ring ಎರಡು ಆಗುತ್ತೆ. face of the disc ಅಂತ ಬರ್ತಿದ್ದೀನಿ. disc ಅಂದ್ರೆ ಇಲ್ಲಿ annular ring ಇದು. ಯಾಕೆಂದ್ರೆ ಮಧ್ಯದಲ್ಲಿ ಖಾಲಿ ಭಾಗ ಇದೆ, ಅದು ಬಿಟ್ಟು ಉಳಿದಿದ್ದೆಲ್ಲ ಡಿಸ್ಕ್ ಶೇಪ್ ಅಲ್ಲೇ ಇದೆ. ಓಕೆ. ಸೊ ಹಾಗಾಗಿ ಏರಿಯಾ ಆಫ್ ದ ಫೇಸ್ ಆಫ್ ದ ಡಿಸ್ಕ್ ಇಸ್ ವೆರಿ ಸಿಂಪಲ್. ಸೊ ಇಟ್ ಇಸ್ ಏರಿಯಾ ಆಫ್ ದ ಔಟರ್ ಮೋಸ್ಟ್ ಸರ್ಕಲ್ ಮೈನಸ್ ಏರಿಯಾ ಆಫ್ ದ ಇನ್ನರ್ ಸರ್ಕಲ್. ಏರಿಯಾ ಆಫ್ ದ ಔಟರ್ ಮೋಸ್ಟ್ ಸರ್ಕಲ್ is pi r2 square and area of the innermost circle is pi r1 square. So therefore area bounded by the ring are the face of the disc is so outermost area minus innermost area. Area of the outer circle minus area of the inner circle. So therefore it is pi r2 square minus pi r1 square. Pi ಕಾಮನ್ ತಗೊಂಡ್ರೆ so pi times r2 square minus r1 square. Okay, ಇದು ಗೊತ್ತಾಯ್ತಲ್ಲ ಇದು?
Yes, sir.
Yes. So this is a disc. This is a circular disc with a hole in the center. And this disc with a hole in the center is actually called annular ring. And the inside circle has a radius of r1. Outside circle or outermost edge has a radius of r2. So therefore area of the disc with the hole or area of the annular ring is simply equal to, so area differences between the two circles, pi r2 square minus pi r1 square r, it is pi into r2 square minus r1 square. So therefore this is area of the ring is pi times r2 square minus r1 square. Now what is the mass per unit area of the ring at for disc? So it is total mass of the disc, total mass of the ring, total mass of the ring capital M ಅಂತ ತಗೊಂಡಿದ್ರೆ divided by area ಮಾಡ್ಕೋಬೇಕು. area ಈಗ ತಾನೇ previous step ಅಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿದ್ವಿ. It is pi times r2 square minus r1 square. Okay na? So therefore mass per unit area of the given annular ring is mass divided by area. Mass is capital M and area is pi times r2 square minus r1 square. Okay na?
Yes, sir.
Oh,
Yes,
okay.
sir.
Okay. Next one. So we want to find out moment of inertia of this circular disc. The circular disc with a hole ಅಥವಾ annular ring ಅಂತಾನೆ ಕರಿತೀವಿ. Circular disc ಅಂದ್ರೆ ಮತ್ತೆ ನೀವು previous one ಗೆ ಕನ್ಫ್ಯೂಷನ್ ಮಾಡ್ಕೊತೀರಾ. ಇದು ಸರ್ಕ್ಯುಲರ್ ಡಿಸ್ಕ್ ಮತ್ತೆ ಅದರ ಸೆಂಟರ್ ಅಲ್ಲಿ ಹೋಗಿದೆ. ಬಟ್ anyhow ಅದನ್ನ annular ring ಅಂತಾನೆ ಕರೆಯೋಣ. So we want to calculate moment of inertia of this annular ring about an axis passing through the point O center and perpendicular to its plane. Okay, so here in the first case we are calculating the moment of inertia about an axis passing through the center. Center ಮೂಲಕ ಪಾಸ್ ಆಗ್ತಾ ಇದೆ ಒಂದು, ಮತ್ತೆ ಈ ಪ್ಲೇನ್ ಆಫ್ ದ ರಿಂಗ್ ಅಥವಾ ಪ್ಲೇನ್ ಆಫ್ ದ ಡಿಸ್ಕ್ ಏನಿದೆ ಅದಕ್ಕೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿದೆ. ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿದೆ ಅಂತಂದ್ರೆ the direction is pointed towards us, ನಮ್ ಕಡೆ ಪಾಯಿಂಟ್ ಆಗಿದೆ, ಅಥವಾ ನಮ್ಮಿಂದ ಆ ಕಡೆಗೆ ಉಲ್ಟಾ ಸೈಡ್ ಆಪೋಸಿಟ್ ಸೈಡ್ ಪಾಯಿಂಟ್ ಆಗಿರಬಹುದು. ಬೋತ್ ಆಫ್ ದೆಮ್ ಆರ್ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಡೈರೆಕ್ಷನ್ಸ್. ಓಕೆನಾ? ಸೊ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ about this axis passing through the center and perpendicular to the plane, what we have to do is we ring ಒಳಗಡೆ we have to take one small element. We are considering one small element inside the annular ring, and this element is actually represented by a circle with the shaded area. ಒಂದು ಲೈನ್ ಎಳೆದಿದ್ದೀವಿ ನೋಡಿ, ಸ್ಟ್ರೈಪ್ ಮಾಡಿದೀವಲ್ಲ, ಅದೇ ಇವು ನಿಮ್ಮ ಎಲಿಮೆಂಟ್ ಆಗುತ್ತೆ. So therefore what we want to do is first we want to calculate moment of inertia of this shaded portion. It is called the element. So we want to calculate moment of inertia of this element, and therefore afterwards we want to calculate moment of inertia of the entire annular ring. Okay, so ಪ್ರತಿ ಕೇಸಲ್ಲೂ ಕೂಡ moment of inertia ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕಾದ್ರೆ we calculate moment of inertia of one small portion. Okay, and then we calculate moment of inertia of the entire object. ಇಡೀ ಆಬ್ಜೆಕ್ಟ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋ ಬದಲು ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಆ ಇಡೀ ಆಬ್ಜೆಕ್ಟ್ ಅಲ್ಲಿ ಒಂದು ಸ್ಮಾಲ್ ಪೋರ್ಷನ್, ಒಂದು ಚಿಕ್ಕದು ಪೋರ್ಷನ್ ಮೂಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತೀವಿ. ಆಮೇಲೆ ಇಡೀ ಆಬ್ಜೆಕ್ಟ್ ಗೆ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಕೊತೀವಿ. ಇಡೀ ಆಬ್ಜೆಕ್ಟ್ ಗೆ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋದು ಅಂದ್ರೆ ಇಂಟಗ್ರೇಷನ್ ಮಾಡ್ಕೊಳ್ಳೋದು, ಅದು ತುಂಬಾ ಈಸಿ. ಸೊ therefore here for us the small portion is this ring. one small ring ಇದೆ ನೋಡಿ, this shaded portion, this is the ring. Okay, so for this particular ring we want to find out moment of inertia. This ring is also called elemental ring. That was ಸುಮ್ಮನೆ ಎಲಿಮೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಓಕೆನಾ? So this element has a radius of x. I think you can see this element, this shaded circle has a radius of x and it has a thickness, and the thickness is dx. Just clear ಆಗಿ ಗೊತ್ತಾಯ್ತಲ್ವಾ ನಿಮಗೆ?
Yes, sir.
Okay, okay. Now, so that is what I have written here. Consider a coaxial disc or ring. This coaxial ring ಇದೆಯಲ್ಲ, that is what the shaded circle we are considering. So it has an inner radius of x and outer radius of x plus dx, so that the thickness dx ಆಗುತ್ತೆ. What is the area of the ring? Area of the ring is very simple. It is area of the innermost circle, sorry, circumference of the innermost circle. Circumference of the innermost circle is 2 pi x ಆಗುತ್ತೆ into thickness dx ಆಗುತ್ತೆ. This approach we used even in the case of circular disc yesterday, ಅಲ್ವಾ? The same approach we are using here. Area of the ring ಇಲ್ಲಿ ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ, ರಿಂಗ್ ಅಂತಂದ್ರೆ ಸೊ ಇಡೀ annular ರಿಂಗ್ ಅಲ್ಲ, ಈ ರಿಂಗ್ ಒಳಗಡೆ ಒಂದು ಸ್ಮಾಲ್ ರಿಂಗ್ ತಗೊಂಡಿದೀವಿ ನೋಡಿ, ಶೇಡ್ ಮಾಡಿದೀವಲ್ಲ, ಆ ಶೇಡ್ ಮಾಡಿರೋ ರಿಂಗ್ ಇದು ಒಂದು ಸ್ಮಾಲ್ ಎಲಿಮೆಂಟ್ ಆಗುತ್ತೆ, ಸ್ಮಾಲ್ ಪೋರ್ಷನ್ ಆಗುತ್ತೆ. ಅದರದ್ದು ಏರಿಯಾ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಅದ್ರ ಏರಿಯಾ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡೋದು ಹೇಗೆ ಅಂತಂದ್ರೆ ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್. ಅದರ ಸರ್ಕಂಫರೆನ್ಸ್ ತಗೋಬೇಕು. ಸೊ ರೇಡಿಯಸ್ x ಆಗಿರೋದ್ರಿಂದ ಸರ್ಕಂಫರೆನ್ಸ್ becomes 2 pi x into its thickness dx. So therefore area of the shaded ring, elemental ring, is 2 pi x dx. Now what is mass of the ring? Mass of the ring is very simple. It is mass per unit area of the entire annular ring, which is m divided by pi times r2 square minus r1 square, ಅದನ್ನ previous step ಅಲ್ಲಿ ಹೇಳಿದೆ, into area of the ring. Area of the ring, elemental ring, is 2 pi x dx ಆಗುತ್ತೆ. So you can cancel pi here, and therefore you can write mass of the ring as 2 times m divided by r2 square minus r1 square into x into dx. Okay na? So this is what the expression for the mass of the shaded ring, elemental ring. Okay na? Now I want to calculate moment of inertia of this ring about an axis passing through the center and perpendicular to its plane. It's very simple. Mass, moment of inertia find out ಮಾಡೋದು ತುಂಬಾ easy. Mass of the ring ತಗೋಬೇಕು into square of the perpendicular distance. See the diagram here. So our circle is at a distance of x from the center O through which the axis is passing. So therefore the distance between the axis of rotation which is passing through O and edge of the ring is x. So therefore square of the distance is x square ಆಗುತ್ತೆ. So therefore I have to multiply mass of the ring with x square. So therefore mass of the ring times x square is nothing but moment of inertia of the ring. So therefore it is 2m times r2 square minus r1 square, 2m times divided by r2 square by minus r1 square into x dx into square of the distance x square ಆಗುತ್ತೆ. So therefore x square x ಜೊತೆ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡ್ಕೊಂಡು it becomes 2 times m divided by r2 square minus r1 square into x cube into dx, because x into x square x cube ಆಗುತ್ತೆ. ಓಕೆನಾ? ಇಲ್ಲಿವರೆಗೂ ಫಾಲೋ ಮಾಡಿದ್ರಾ?
Yes, sir.
Okay. Now I don't want moment of inertia of this elemental ring. I want the moment of inertia of the entire ring annular ring. Okay. So how do we calculate moment of inertia of the entire ring? It's very simple. What we have to do is we have to do the integration not from the center. Center in the integration ಮಾಡಬಾರ್ದು. ಇಲ್ಲಿ 0 to r2 ಆಗೋದಿಲ್ಲ. ಯಾಕೆಂದ್ರೆ ಸೆಂಟರ್ ಒಳಗಡೆ ಒಂದು ಹೋಲ್ ಇದೆ, ಅಲ್ಲಿ ಮ್ಯಾಟರ್ ಇಲ್ಲ, ಅದು ಆಬ್ಜೆಕ್ಟ್ ಇಲ್ಲ. ಸೊ ಹಾಗಾಗಿ ನೀವು ಇಂಟಗ್ರೇಷನ್ ಮಾಡಬೇಕಾಗಿರೋದು r1. The lower integral limit is r1 and the upper limit integral limit is r2. Okay, ಫಾಲೋ ಮಾಡಿದ್ರೆ ಗೊತ್ತಾಯ್ತಾ? ಯಾಕೆಂತಂದ್ರೆ 0 to r ಅಂತ ತಗೊಳ್ಳೋದಕ್ಕೆ ಸೆಂಟ್ರಲ್ಲಿ ಖಾಲಿ ಜಾಗ, ಯಾಕೆಂದ್ರೆ ಅದು ರಿಂಗ್ ಅಂದ್ರೆ ಮಧ್ಯಭಾಗ ಖಾಲಿ ಇರುತ್ತೆ. ಸೊ ಹಾಗಾಗಿ integration limits are not from 0 to r2. It is from the inner edge of the ring. Inner edge of the ring has a distance of the radius r1 ಇದೆ. So outer edge r2 ಇದೆ. So therefore integration should be carried from r1 to r2. Okay. So therefore moment of inertia of the ring becomes integral r1 to r2 into moment of inertia of the ring. Moment of inertia of the ring is 2 times m divided by r2 square minus r1 square x cube. So into dx ಆಗುತ್ತೆ. So ಅದನ್ನೇ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದೀನಿ. I is equal to integral r1 to r2 2m divided by r2 square minus r1 square into x cube into dx ಆಗುತ್ತೆ ಅಲ್ವಾ? I can take 2m divided by r2 square minus r1 square outside. So therefore I am left with integration of x cube. Okay, what is integration of x cube?
X to the power of 4 by 4.
Yes, it's very simple. ಎಲ್ಲ ಈಗ ನಿಮ್ಮ ಪ್ರತಿಯೊಂದು ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಅಲ್ಲೂ ಕೂಡ ಸೊ ನಿಮ್ಮ ಇಂಟಗ್ರೇಷನ್ ಸಿಂಪಲ್ ಇಂಟಗ್ರೇಷನ್ ಮಾತ್ರ ಬರುತ್ತೆ. ಸೊ ಹಿಯರ್ ಇಂಟಗ್ರೇಷನ್ ಆಫ್ x cube, it is x to the power of 3 plus 1 divided by 3 plus 1. That means x to the power of 4 divided by 4 ಬರುತ್ತೆ. So therefore integration of x cube is x to the power of 4 by 4. So integral limit r1 to r2. upper limit r2 ಆಗುತ್ತೆ, lower limit r1 ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ರಿಂಗ್ ಗೆ ಇನ್ನರ್ ಸರ್ಕಲ್ ಅಥವಾ ಇನ್ನರ್ ಎಡ್ಜ್ ರೇಡಿಯಸ್ r1 ಇದೆ, outer edge circle r2 ಇದೆ. ಹಾಗಾಗಿ integral limits r1 r2 ಆಗುತ್ತೆ. Okay. So therefore I is equal to 2m divided by r2 square minus r1 square into, I am substituting the upper limit. So therefore it is r2 to the power of 4 minus lower limit ಹಾಕಿದ್ರೆ minus r1 to the power of 4. So divided by 4 ಹಾಗೆ ಇದೆ. So if I simplify this, so 2 cancel ಆಗುತ್ತೆ. Numerator 2 ಇರೋದು, denominator 4 ಇರೋದು, denominator 2 ಆಗುತ್ತೆ. So therefore it is m by 2 times r2 square plus r1 square. ಈ ಸ್ಟೆಪ್ ಹೇಗೆ ಬರುತ್ತೆ ಯಾರಾದ್ರೂ ಹೇಳ್ತೀರಾ? Okay. So therefore the expression for the moment of inertia of the annular ring about an axis passing through the center perpendicular to the plane is very simple. It is m times r2 square plus r1 square divided by 2. Yeah, what are r1 and r2? r1 is the radius of the inner edge of the ring. r2 is the radius of the outer edge of the ring. That's it. Okay. Similarly, you can find out radius of gyration. How do you find that radius of gyration? It's very simple. You equate it to mk square. mm cancel ಆಗುತ್ತೆ. So therefore k square becomes equal to r2 square plus r1 square divided by 2. So therefore radius of gyration k becomes equal to square root of r2 square plus r1 square divided by 2. ಆಯ್ತಾ? ಇದಿಷ್ಟು ಗೊತ್ತಾಯ್ತಾ? ತಲೆ ಹೋಯ್ತಾ?
Yes, sir. Yes, sir.
Okay. Now let us move on to the next position. So next we want to find out moment of inertia of the ring, same annular ring, same object, but about an axis passing through its diameter. Okay. So here we are trying to find out moment of inertia about an axis passing through the diameter. Okay. So diameter ಅಂತಂದ್ರೆ ಇಲ್ಲಿ ವರ್ಟಿಕಲ್ ಆಗಿ ಪಾಸ್ ಆಗುತ್ತೆ. ಹೀಗೆ ನಾನು ಅದರದ್ದು ಡಯಾಗ್ರಾಮ್ ಬರ್ದಿಲ್ಲ, ಬಟ್ ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್. ಓಕೆ, ಸರ್ಕ್ಯುಲರ್ ಡಿಸ್ಕಲ್ ಕೇಸ್ ಅಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ವು, ಆನ್ಯುಲರ್ ರಿಂಗ್ ಅಲ್ಲೂ ಕೂಡ ಸೇಮ್ ಅದೇ ಕೇಸ್ ನ ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ therefore I want to find out moment of inertia about an axis passing through the diameter of the annular ring. Okay. So in order to find out moment of inertia, so what we are going to do is we are going to consider two perpendicular direction. This is one perpendicular direction, this is the second perpendicular direction. Na diagram ಬರ್ದಿಲ್ಲ, ಹಾಗೆ explain ಮಾಡ್ತಾ ಇದೀನಿ, ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡಿ, ಕರ್ಸರ್ ಕೂಡ ನೋಡ್ತಾ ಇರಿ. This is one diameter and this is the second diameter. So let us say first diameter is along y axis, second diameter along x axis. Okay, since circular annular ring has a circular symmetry, so therefore the two diameters are same. So therefore moment of inertia through the diameter, let us take it as I1. So moment of inertia about an axis passing through this diameter is I1. Moment of inertia about an axis passing through your x axis is also I1, and both of them are equal because so it has your ring has a circular symmetry, and according to perpendicular axis theorem, moment of inertia through this axis y axis I1 plus moment of inertia through x axis I1. I1 plus I1 must be equal to moment of inertia about z axis. What is moment of inertia about z axis? Moment of inertia about z axis is the thing that we have calculated just now. So therefore I becomes equal to I into m to r2 square plus r1 square divided by 2. So therefore, using perpendicular axis theorem, you can find out moment of inertia very easily. So moment of inertia about y-axis I1, moment of inertia about y-axis is also I1. So I1 plus I1, that is Ix plus Iy, Ix plus Iy should be equal to Iz according to perpendicular axis theorem. And Iz is nothing but the moment of inertia about an axis passing through the center and perpendicular to the plane. That is what the thing we calculated previously. So therefore, that must be equal to m times r2 square plus r1 square divided by 2. So I1 plus I1 is 2I1. So 2 na right side ಗೆ ಕಳಿಸ್ತಾ ಇದೀನಿ. So therefore, I1 becomes equal to m times r2 square plus r1 square divided by 2 into 2, 4 ಆಗುತ್ತೆ. So therefore, expression for the moment of inertia of an annular ring about an axis passing through any of its diameter is given by mass times r2 square plus r1 square divided by 4. Okay na?
Yes, sir. Yes,
Okay.
sir.
Now the respective radius of gyration is very simple. How do you find out? You equate it to mk square. So I have written it as mk1 anta bardidini. Previous case ಅಲ್ಲಿ k anta bardidde ಈ k1 anta ಬರ್ಕೊಂಡಿದ್ದೇನೆ. So therefore this must be equal to mk1 square. So m cancel ಆಗುತ್ತೆ. So therefore k1 square becomes equal to r1 square plus r2 square divided by 4. So therefore k becomes equal to square root of r2 square plus r1 square, and square divided by square root of 4 is nothing but 2. So therefore the radius of gyration of the annular ring about an axis passing through the diameter, I have written it as k1. So k1 is equal to square root of r2 square plus r1 square divided by 2. Okay na gotaita?
Yes, sir.
Okay, now let us go to the next one. Actually, we can find out another case also. Tangential axis anta ninne circular scheme madadvalla, illu kuda tangential axis anta tagobodu, but I have avoided, nanu adanella avoid madidini. By making use of parallel axis theorem, it is possible to calculate moment of inertia about a tangential axis. Okay, so and through the plane of the circular ring ಮಾಡಬಹುದು. I mean circular ring alla annular ring aguttadu. So therefore adu tumba easy, and we can calculate it using the parallel axis theorem, but na case tanbittidini. Okay na? But anyhow, we want to go for a special case. Okay, so the special case is moment of inertia of a thin ring. Sorry, I'm extremely sorry. Thin ring anta agobitide. It is not thin ring. It is thin ring. THIN. Thin ring. Nimge notes ಕಳಿಸೋದಕ್ಕಿಂತ ಮುಂಚೆ ಇದನ್ನೆಲ್ಲ ಕೂಡ ಕರೆಕ್ಷನ್ ಮಾಡಿ ಕಳಿಸ್ತೀನಿ ನಾನು. What is a thin ring? Can somebody say what is a very thin ring? ತುಂಬಾ ತೆಳ್ಳಗಿರೋ ring ಅಂತ thin ring ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ?
Thin ring.
Can somebody say what is a thin ring? For example, ಹುಡುಗಿರ ಕೈನಲ್ಲಿ ನೀವು ಬಳೆ ಹಾಕೊಂಡಿರ್ತೀರಲ್ವಾ ನೀವು, that ಬಳೆ so is actually an example for thin ring. ಯಾಕೆ thin ring ಅಂತ ಕರಿತೀವಿ ಅಂತಂದ್ರೆ ಅದರದ್ದು thickness ತುಂಬಾ ಅಂದ್ರೆ ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಲ್ವಾ? ಎಷ್ಟು ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ ನಿಮ್ಮ ಬಳೆದ thickness ಅಂತಂದ್ರೆ ಅದರದ್ದು ಇನ್ನರ್ ರೇಡಿಯಸ್ r1 ಮತ್ತೆ ಔಟರ್ ರೇಡಿಯಸ್ ಇನ್ನರ್ ರೇಡಿಯಸ್ r1 ಔಟರ್ ರೇಡಿಯಸ್ r2 ಇದೆಯಲ್ಲ, both the values they are very close to each other. So therefore for a thin ring, so r1 is approximately equal to r2. In the case of ordinary annular ring, r1 and r2 are completely different. r1 ಮತ್ತೆ r2 ಎರಡು ಬೇರೆ ಬೇರೆ ಇರುತ್ತೆ. But if you go to the special case of thin ring, then r1 is approximately equal to r2. Okay, such that the thickness of the ring is very very small, so that you can neglect, and you can assume that so both inside circle and the outside circle have the same radius. Therefore r1 is approximately equal to r2, and that is one we are taking it as r. Okay, so therefore the moment of inertia ಏನಾಗುತ್ತೆ ನೋಡಿ. So moment of inertia of a thin ring about an axis passing through the center and perpendicular to the plane. Remember, we derived the expression for the general case of the ring I is equal to m plus r2 square plus r1 square divided by 2. But for a thin ring, r1 is approximately equal to r2, and that one we are writing it as r. So therefore it is r square plus r square divided by 2. So r square plus r square divided by 2 is 2r square. 2 cancel agutte. So therefore the moment of inertia becomes equal to mr square. So the moment of inertia of a very thin ring about an axis passing through the center and perpendicular to the plane is mass times square of the radius mr square. ಹೌದಾ ಗೊತ್ತಾಯ್ತಾ ಇದು?
Yes,
Yes, sir. Yes, sir.
Okay. Now, how do we calculate moment of inertia of the same thin ring about an axis passing through the diameter? It is also very simple. Moment of inertia expression about an axis. So passing through the diameter is m times r2 square plus r1 square divided by 4 ಅಂತ ಮಾಡಿದ್ವಿ. ಇಲ್ಲೂ ಕೂಡ ನಾವೇನ್ ಮಾಡ್ಬೇಕು, so r1 approximately equal to r2 is equal to r ಅಂತ ಹಾಕೋತಾ ಇದೀವಿ. So therefore moment of inertia becomes I1 is equal to m times r square plus r square divided by 4. So r square plus r square divided by 4 is nothing but, so m2 r square, 2 divided by 4 is 1 by 2. So therefore moment of inertia becomes m r square divided by 2. So therefore moment of inertia of a thin ring about an axis through its diameter is m r square divided by 2. ಆಯ್ತಾ? ಇದಿಷ್ಟು rectangular lamina ಅಥವಾ rectangular disc. Rectangular lamina, rectangular disc, same. Remember we calculated moment of inertia of a circular disc, then we calculated moment of inertia of an annular ring, and we also found out expression for the moment of inertia of very thin ring. Now we want to find out moment of inertia of a rectangular disc. Okay, so it is rectangular disc or it is rectangular, so lamina, both are same. Okay, so first we want to calculate moment of inertia of a rectangular disc about an axis passing through the center and parallel to breadth. Okay, so this is our circular disc. A, B, C, D is our circular disc. Sorry, rectangular disc. Okay, so this is the center. Y and Y dash is the line that is actually passing through the center. Y dash, I hope you can see, Y dash is the axis of rotation. Axis of rotation is actually passing through the center, and it is passing in such that, so this axis is parallel to breadth. AD is breadth, BC is also breadth. So the axis of rotation is parallel to breadth, either AD or BC. Okay, that's why we are calculating moment of inertia about an axis passing through its center and parallel to its breadth. Okay na? So parallel to length ಕೂಡ ಮಾಡಬೇಕು, ಅದನ್ನ ಆಮೇಲೆ ನೋಡೋಣ. ಫಾಲೋ ಮಾಡ್ತಾ ಇದ್ದೀರಲ್ಲ?
Yes, sir.
Okay, let us take capital M is mass of the disc. Capital M is mass of the rectangular disc. L is small l is length of the disc. So this AB or CD, AB or CD is the length. Length is a small l. AD or BC is the breadth, and breadth is a small. Okay, so therefore we are considering a rectangular disc of mass capital M, length small l, and breadth small letter b. Y dash is the axis of rotation passing through the center, and the axis of rotation is also parallel to breadth. Breadth ge parallel agide. Okay, so area of the lamina is very simple. It is length into breadth. It is L into B. Hodala?
Yes, sir.
Okay, next mass per unit area of the rectangular disc ಏನಾಗುತ್ತೆ? Mass per unit area of the rectangular disc is very simple. Total mass divided by total area. Mass of the disc is capital M. Area of the disc is L into B. Area is L into B because it is a product of length into breadth. Okay na? So that is what the thing. Now, so to calculate moment of inertia about an axis with respect to Y dash, we are considering one small portion. ಪ್ರತಿಯೊಬ್ಬ ಕೇಸಲ್ಲೂ ಕೂಡ moment of inertia of the entire object calculation ಮಾಡೋದಕ್ಕಿಂತ ಮುಂಚೆ ಒಂದು ಸ್ಮಾಲ್ ಪೋರ್ಷನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿಕೊಂಡು ಆ ಸ್ಮಾಲ್ ಪೋರ್ಷನ್ ಗೆ ನಾವು moment of inertia ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ, ಆಮೇಲೆ ಎಂಟೈರ್ ಆಬ್ಜೆಕ್ಟ್ ಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀವಿ. The same procedure we are following here also. Okay, so therefore there is one small section of the disc. The small section of the disc is one thin patch. ಒಂದು ಚಿಕ್ಕದೊಂದು ಪ್ಯಾಚ್ ತರ ಇದೆಯಲ್ಲ, ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ. ಸೊ ಎರಡು ಲೈನ್ ಎಳೆದ್ಬಿಟ್ಟು ಮಧ್ಯದಲ್ಲಿ ಸೊ ಕ್ರಾಸ್ ಆಗಿ ಲೈನ್ ನ ಕ್ರಾಸ್ ಮಾಡ್ಕೊಂಡಿದೀವಿ. So that is our small patch. That is our small element. So this element has a thickness of dx. Has a thickness of dx. What is the breadth of this? What is the breadth of this disc? ಕೇಳಿಸಿದ್ಯಪ್ಪ?
x plus dx.
I want to know. So okay, adana question ಆಮೇಲೆ ಕೇಳ್ತೀನಿ. Just again listen to me carefully. So this is a small patch in the rectangular disc. This small patch in the rectangular disc has a thickness of dx. Okay na? And this small patch is at a distance x from the axis of rotation y dash. The small patch of the disc is situated at a distance x from the axis of rotation y dash, and this small patch has a thickness of dx. Can somebody say what is the area of this small patch? Come on, tell me quickly. Idon case adra bega mugisbidtini. Can somebody say what is the area of this small patch? This small patch ಅಥವಾ small area ಕಾಣಿಸ್ತಿದೆಯಲ್ಲ, ಅದರ area ಹೇಳ್ತೀರಾ? It has a thickness of dx and it has a length, and that length is same as the breadth of the disk bc. So therefore it is b into dx. So therefore I can conclude area of this element, area of this small patch, the area of the strip is b into dx. b is the breadth ಅಥವಾ length of the patch ಆಗುತ್ತೆ, dx is the thickness ಅಲ್ವಾ. ಸೊ ಇದು ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಶೇಪ್ ಅಲ್ಲಿ ಇದೆ. ಈ ಸ್ಮಾಲ್ ಪ್ಯಾಚ್ ಅಥವಾ ಸ್ಮಾಲ್ ಸ್ಟ್ರಿಪ್ ಇದೆಯಲ್ಲ, ಇದು ಕೂಡ ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಶೇಪ್ ಅಲ್ಲಿ ಇದೆ. ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಶೇಪ್ ಅಲ್ಲಿ ಇದ್ದಾಗ ಏರಿಯಾ ಹೇಗೆ, ಸೊ ಇಟ್ ಈಸ್ ಈ ಲೆಂತ್ ಆಗುತ್ತೆ, ವರ್ಟಿಕಲ್ ಲೆಂತ್ ಹಾರಿಜಾಂಟಲ್. ವರ್ಟಿಕಲ್ ಲೆಂತ್ ಬಿ ಸ್ಮಾಲ್ ಬಿ, ಬ್ರೆಡ್ತ್ ಆಫ್ ದ ಡಿಸ್ಕ್ ಆಗುತ್ತೆ. ಹಾರಿಜಾಂಟಲ್ ಲೆಂತ್ ಏನಾಗುತ್ತೆ dx, because it has a thickness dx. So therefore area of the disk, area of the shaded area, the area of the strip is b dx. Now what is mass of the strip? Mass of the strip is nothing but mass per unit area of the disk into area of the strip. So mass of the strip is mass per unit area of the disk, okay, which is nothing but capital M divided by L into B, into area of the strip. Area of the strip is nothing but b dx. So therefore small b cancel ಆಗುತ್ತೆ. Mass of the strip comes out to be capital M divided by L into dx. Capital M is mass of the disk, small l is length of the disk, dx is the thickness of the patch, thickness of the strip, that was thickness of the element. Okay, now I don't want mass of the strip, I want moment of inertia of the strip. So what is moment of inertia of the strip? Moment of inertia of the strip is very simple, mass of the strip into square of the distance. Mass of the strip is capital M divided by L into dx. So square of the distance means, so I have already shown in the diagram, this strip is at a distance of x from the axis of rotation y dash. So therefore square of the distance is nothing but x square. So therefore I can say that, so moment of inertia of the strip, or moment of inertia of the shaded area, or moment of inertia of the element is M divided by L into x square into dx. Alva? Now this is what moment of inertia of one small strip. But remember, the whole rectangular lamina is actually consisting of large number of such strips. ನಿಮ್ಮ ಇಡೀ ಸ್ಟ್ರಿಪ್ ಒಳಗಡೆ ಅಥವಾ ಇಡೀ ರೆಕ್ಟಾಂಗ್ಯುಲರ್ ಡಿಸ್ಕ್ ಅಲ್ಲಿ ಬರೀ ಒಂದು ಸ್ಟ್ರಿಪ್ ಇಲ್ಲ, ಆ ತರ ತುಂಬಾ ಸ್ಟ್ರಿಪ್ಸ್ ಗಳಿದೆ. ಎಲ್ಲಾ ಸ್ಟ್ರಿಪ್ಸ್ ಗಳದ್ದು ಮೊಮೆಂಟ್ ಆಫ್ ಇನರ್ಷಿಯಾ ತರ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡ್ಕೊಂಡು ಸಮ್ ಮಾಡಬೇಕು. Summation is nothing but your integration. So therefore I can conclude that the moment of inertia of the rectangular lamina at the rectangular disk is, so IL ಅಂತ ಬರ್ತೀನಿ, this is I subscript L is equal to integral minus L by 2 to plus L by 2, so times M by L into x square into dx. Now can somebody say why the limits are minus L by 2 to plus L by 2? Why the integral limits are minus L by 2 to plus L by 2? You can see the diagram and you can tell me why the integral limits are so minus L by 2 to plus L by 2. Okay, so therefore the integration limits are from minus L by 2 to plus L by 2, because one side of the disk has a coordinate of minus L by 2, other side has a coordinate of plus L by 2. So therefore integration ಮಾಡಬೇಕಾದ್ರೆ m by L constant, you can take it outside, m by L is constant. So integration of x square dx, integration of x square is x cube by 3. I think that is very easy, x cube by 3. Okay, and you have to substitute the limit plus L by 2 to minus L by 2. So it is m divided by 3L, 3 ಆಚೆ ಬರುತ್ತೆ, so IL becomes equal to m divided by 3L. Okay, so x cube ಅಂದ್ರೆ L by 2, L by 2 whole cube, L by 2 whole cube is nothing but L cube divided by 2 cube is 8, minus of minus L by 2 whole cube, minus L by 2 whole cube is nothing but minus L cube by 8 ಆಗುತ್ತೆ. So therefore this becomes minus into minus plus, so this becomes 2L cube divided by 8 or L cube divided by 4. So that 4 multiplies with the 3, it becomes a 12. ಇಲ್ಲಿ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ L cube ಇದೆ, ಡಿನಾಮಿನೇಟರ್ ಅಲ್ಲಿ L ಇದೆ, ಒಂದು L ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. So therefore the moment of inertia actually becomes m L square divided by 12. So therefore we can conclude moment of inertia of a circular disk about an axis, moment of inertia of a rectangular disk about an axis passing through the center and parallel to breadth is given by ml square by 12, where L is the length of the rectangular disk. Okay, so now radius of gyration is very simple, you can substitute it as m k L square ಅಂತ ಬರ್ಕೋಬಹುದು, mf cancel ಆಗುತ್ತೆ. So therefore the radius of gyration actually becomes kl is equal to L divided by 2 root 3, square root of 12 is 2 root 3. So therefore radius of gyration actually becomes kl is equal to L divided by 2 root 3.